Okay, this is the midterm exam for Physics 203. This is similar to the midterms for Physics 103 as well. The first one is, what is the measurement given by this caliper in centimeters? First, we want to look at where the 0 mark is. The 0 mark is between 0.8 and 0.9, so we know that it's 0.8 something, and then we look along until we find a mark on the bottom that lines up with the mark on the top, and it's right here at 8. So it's going to be 0.8, that's from over here, and then the second is 8, that's from right here, and then the last is 0.880. So the answer is C. From this graph, what are the units of the slope? Well, it's rise over run, that is meters over seconds. So for number 2, the answer is A. This graph gives the position of a particle over time of 5 seconds. What's its instantaneous velocity at 0.75 seconds? At 0.75, that's roughly right here. So we just want to know the slope of this line. It has a rise of 4, a run of 1. It's 4 over 1, so it's A. The following are two vectors. What best gives A plus B? Here's the vector A. There's the vector B. So our vector C looks like this. So it's B. The answer is B. Number 5, you drop a bouncy ball on the floor and it bounces back up. Well, initially, which of these best describes the motion of the ball, the velocity versus time? If you drop a bouncy ball, it initially has a negative velocity that's increasing in the negative direction, like right here, and then it bounces, and it immediately gets a big positive velocity that is decreasing in the positive direction. So the answer is D for that one. All right, what is the standard error in the following set of numbers? The first thing you have to do is find the average. I'm going to call it X bar. X bar is the sum of all of them divided by the number of numbers. So it's 13 plus 7 plus 11 plus 9 divided by the number of numbers in the sample. That's 20 plus 20, 40 over 4. So the average is 10. And then the standard error is the sum of x minus x bar, absolute value, squared over n minus 1. So putting this in, I get the square root of 13 minus 10 squared plus 7 minus 10 squared plus 11 minus 10 squared plus 9 minus 10 squared. This is all divided by 4 times 3. 4 times 4 minus 1, which is 4 times 3. Notice that the n minus 1 is also under the square root. A number of people didn't square root that 12, but it has to be square rooted as well. Put this in your calculator, you get 1.3. All right, sketch the, oh, by the way, this was worth 3 points. Number 7 was worth 2 points. Sketch the y velocity versus time graph for a ball that's thrown upwards, goes up, and returns to its original position. All right, so I'm looking for a ball that goes up, up, and then back down again. All right, its y velocity, Vy, versus t looks like this. It initially has a big velocity in the positive direction that decreases. It's 0 at the top, and then it increases in the negative direction until it comes back to your hand. So that's number 7. Number 8, which was worth 4 points. 4 points. Sketch the x and y components of a ball in projectile motion. The x component of the velocity, Vx versus t. The x velocity doesn't change because that acceleration is 0 in the x direction, so it looks like that. And then Vy versus t looks like it did in the previous problem because it's the same scenario. All right, it's going up and then coming back down again. So Vy looks just like from problem 7. Number 9, which was worth 7 points. This was worth 7 points. Use trigonometry, calculate the sum of these two vectors. I'm going to use a table. I'll calculate my x and my y components, vector A, vector B. The x component of A is 20 cosine of 50. The y component is 20 sine of 50. For x component of B is going to be 5, and the y component is 0. And then I add up these numbers. This is 17.9. This is 15.3. And to find the magnitude of A plus B, to find the magnitude, it's 17.9 squared plus 15.3 squared. Square root that. Sorry about this. And then that's equal to 23.5. That's in newtons. So that's the magnitude. And then we also need the direction. It's the inverse tan of the y over the x component. That's 15.3 over 17.9. And then that's equal to 40.5 degrees. Above the x-axis. So you're doing the same thing in 10. Number 10, by the way, is worth 9 points. I'm not going to draw it to scale, though in mine, I let 1 centimeter equal 1 newton. So in my scale, I let 1 centimeter equal 1 newton. And so my first vector is going to be 20 centimeters long. So if this is my page, it should look something like this. My first vector is 20 centimeters long at an angle of 50 degrees. And then my second vector is 5 centimeters long in the horizontal direction. So it looks like that. And then my resultant vector will look like this. And the resultant vector should be about 24 centimeters, right? Because I know that it's about that length. So it's about 24 centimeters. And then I should find this angle to be approximately 40 degrees, because that's what I found in number 9. But you should measure them with your ruler and the protractor to get that. And so let's say I found it to be 24 centimeters for the magnitude. To find the percent difference, I say 24 minus 23.5 divided by 23.5 times 100 gives me my percent difference. And that's going to be the value that I put up here. People had very small values for the percent difference. It should be less than 10%. If you had more than 10%, you probably had a mistake somewhere. Okay, number 11 was from the Projectile Motion Lab. This was like parts 1 and 4 of that lab. I know that delta y is 9 meters, or 0.9 meters rather. Delta x is 2.3 meters. I want to find what time passes before the ball strikes the ground. For part A, I have to consider the y motion is 1/2 at squared, because the velocity in the y direction is 0, so I just leave that out. So I have negative 0.9 equals 1/2 minus 9.8 times t squared. Solving that for t, I find that t is equal to 0.43 seconds. So this is 0.43 seconds. What is the initial velocity of the ball? Well, I know that x is equal to v naught x times t. And since the y component of the velocity is 0, then the initial velocity v naught x is equal to the initial velocity of the ball. The x component is the initial velocity of the ball, because the velocity is all in the x direction. So I know these values. This is 2.3 is equal to v naught times 0.43 seconds. And so I can find v naught is 2.3 over 0.43. That's 5.3 meters per second. And then finally in part C, what if I put a target 1 meter from the table? What height would I put it at? Well, first I want to find the time. I know that x is equal to vx times t. That is that 1 meter is equal to 5.3 meters per second times t. And I find that the time when it goes through this target is at a time of 0.19 seconds. And then I want to know what is the y position at that time. So I say y is 1/2 at squared. It's 1/2 minus 9.8 times 0.19 squared. And I find that this is equal to negative 0.18 meters. That means that from here to here, the ball drops 0.18 meters. All right, but I ask actually for this distance. So I say that this distance is 0.9, which is the y position, the initial position, minus 0.18, which is 0.72 meters, or 72 centimeters. I'd take either. All right. Those are the three answers. This one was worth 7 points. And then finally, number 12, this is by far the most missed question, and you're certainly going to see it again on the final. The following data was taken for an object undergoing constant acceleration. The relationship between the two quantities is as follows. Plot the data and interpret to determine the acceleration of the object. So you want to find the acceleration by plotting the data. However, this relationship is not linear, all right, because v and x are not linearly related. They're not linear. There's not a linear relationship between those variables. So I have to make a plot of v squared times versus delta x. And so you would create another column here where you calculate the values for v squared. And plotting it, I would be looking for meters per second squared for the units. The units here are just meters. You will get a straight line. Alright, and then you draw a triangle to show the slope. Delta y, delta x, that's rise over run. So the slope equals rise over run, which in this case the slope turns out to be 10. And you have to interpret that slope. The slope, if you look here, this is our equation. V squared equals 2a delta x. We've plot v squared on the y-axis, x on the x-axis, y is equal to mx. So our slope, m, is equal to 2a. So a, the acceleration, is equal to 5 meters per second squared. All right, that's the problem. Many of you didn't get the graph right, and so you missed a lot of the points. If you got the graph right, you might have missed a few points here or there just for sort of little details. But you'll certainly see this type of problem on the final. And there's your equations. That's all.